Welcome to clickmyproject.com. Let we discuss about the process, a novel image watermarking approach. Let me see the abstract of the process. The common methodology in data embedding is that in the sender side, the data that is to be hidden is placed within the pixel values of the cover image, producing the stego image. In the receiver side, the embedded data in the stego image is retrieved by reversing the same process that is employed for embedding process. The data that is to be hidden is embedded in the images using DCT is proposed. The input, cover and the watermark images were obtained. The obtained images were combined with the help of calculation of average of the cover and the watermark images. The images were converted into string for the transmission of the data. In the receiver side, the string is converted into integers in order to retrieve the data. Watermarking is a basic secure communication method. It is used for embedding a recognizable pattern in media in such a manner that modification of media also modifies the pattern, thus making it easy to detect the modification. This technique and its variants have many practical applications pretending to secure communications, media verifications, etc. Digital image watermarking is a technique for embedding data within an image in such a way that original and the modified images are essentially identical. The embedded data can be used for various purposes such as secure communication in military application, owner identification and verification, content authentication, etc. In the proposed method, watermark image is hidden in a cover image using discrete cosine transformation. The tests of fidelity between the original and watermarked image and the robustness is applied to the watermarked image. The results with both human visual system and graphic aspects were calculated in terms of PSNR and MSE value. The results shows that an embedded watermark is not easily detectable using either HVS or other techniques. Additionally, it can be detected successfully in simulation domains, but it may be susceptible to some noises and channel limitations in real world replaced from the original frames. The performance of the process is measured with the help of PSNR and MSC. Let me see the flow of the process. We first acquire the cover image and the watermark image. DCT is applied to both of the images. Instead of combining directly the cover and watermark, DCT is applied and after that the combination is employed. This will secure the image pixels in the image. After the combination of the two DCT coefficients obtained, the final embedded image is extracted. The final embedded image is obtained by calculating the average of both of the pixels that we have selected. After the calculation of the pixels the pixels were rearranged in the form of a matrix, and finally the embedded image is obtained. The obtained image, the coefficients after the MSB, that is the LSB coefficients, were converted into string, and they are used for the transmission purposes, because we employ the modifications in the MSCs of the images, and hence while we transmit in the form of integers format, and hence we need the coefficients after the MSBs of the input images in order to extract the images more effectively. We transfer the signals using the conversion of the signals in. After that, the extracted in the receiver side, the obtained string coefficients and the embedded images were combined. The string coefficients were converted into integers, and they were combined with the original image pixels, and after that the extraction process is reversed exactly as embedded. That is, the average process is reversed exactly as embedded. After the extraction, the cover image and the watermarked image were obtained separately. The overall performances of the processes were measured in terms of PSNR and MSC of the process. If you want to run the code, first embedding process is run, after that extraction process is run. So first right click the embedding.m file and click on run file. The process gets started. Inside the process we have given the cameraman image as the cover image and the rise image as the watermark image. Now the cameraman image, within the cameraman the image, the rise image is placed, and we obtain the extracted overall embedded coefficients in the process. This process will take some time for the execution, since the obtained images, each calculations has to be done pixel wise, so it will take some time for the execution. So this is the input rise image that is taken as the watermark, and here we can see this is the original image and this is the watermark image, and the two images were shown separately, and finally in this image rise is embedded. So the camera image, the rise image is embedded. So after that we move on to the process of extraction of the watermark from the obtained images. For the extraction of the watermark, run the file extraction. As we can see, the process will take some time, so similar process is repeated for each pixel wise calculations, and after the completion of all the processes, the result will be displayed here. So this is the final extracted watermark that is hidden in the image. As we can see, this is the embedded image and this is the original image. This is the extracted secret images that we have got. So thus we have obtained the extracted watermark by reversing the same process as embedding, and also we have calculated the performance measures with the help of PSNR and the MSC values estimated. Thus, the overall process is the embedding of the watermark image in the cover image and the extraction of the same using the same DCT based informations. Thus, we extract and embed the watermark images inside the secret images, and the overall performances of the processes were measured in terms of PSNR and MSC values. Thank you.